Welcome to this session on debugging OpenTelemetry, ensuring your observability signals are spot on. My name is Kasper. I'm a developer advocate at Dasero. I'm also one of the former co-chairs of KubeCon, Cloud Native Con, EU and North America. I'm a CNCF ambassador. I've been trying my best to get all the certifications within the CNCF ecosystem, so I'm also a Golden Kubestronaut. I organize meetups in Denmark and across the Nordic countries of Europe. We founded this thing called Cloud Native Nordics, which is the snowflake logo you see up on the screen as well. So I try to do a lot of things within the community. I just love this Cloud Native community, and it's awesome to be here today. The TLDR for this talk, I will start out by talking a little bit about what OpenTelemetry is, for those who are not that familiar with it. Maybe a show of hands, how many are using OpenTelemetry today? Okay, good amount of people, but still there's a lot of people that are not using it today. So we will talk a little bit about what it is. Next, we will take a look at some of the common pitfalls and figure out why those metrics are not ending up in the observability tool that I have, because usually it fails very silently, and that can be very hard to figure out. We will look at some language-specific challenges, because each of the SDKs within the OpenTelemetry project has its own quirks, and they may vary a little bit more than you expect. So we will have a look at some demos and some code on how to configure it. And then lastly, we will talk a little bit about some tools and tips for how you can get started debugging OpenTelemetry on your local environments and make sure that your signals are arriving at the right place at the right time. So what is OpenTelemetry? It's a CNCF not sandbox project, incubating project. There's an open PR or issue on the TOC right now for graduation. Hopefully that will happen within a couple of months, but we'll see. It's the second largest project by contributor count, so it's a very active project within the ecosystem. It's a set of various different things. It has a data model, API specifications, SDKs in multiple different languages, has semantic conventions that defines how data should look like, or telemetry should look like, has library implementations, as mentioned, in the SDKs for various different languages, probably all the languages you are using today. It has an OpenTelemetry collector, which is a collector you're running in your cluster that will get the data and forward to some destination, some backend somewhere. And we'll also look at that in a second. But it's not proprietary. It's not an all-in-one observability tool. It's not a data storage layer. It's not a dashboarding solution. It doesn't have a query language. It's not a performance optimizer. So it's really only focusing about how to collect the telemetry and then forward to somewhere else. And it looks something like this, where we have some instrumentation in a service using an SDK. You can do that in many different ways. You can use auto instrumentation, you can do manual instrumentation, and I'll show you a few examples of those as well. Then you send that data to, in many cases, the OpenTelemetry collector. You could also forward it directly, but I would definitely encourage you to use the collector. It's a really great piece of infrastructure to have running to gather all the information from your clusters and forward them, and also enrich the data that are being received. Then it also can help you monitor your infrastructure. So, for example, for Kubernetes, there's a lot of different receivers for cluster events, for kubelet stats, for all the different kind of metrics that you're interested in from an infrastructure perspective in monitoring Kubernetes. And then you send that through the collector, and then you export it to some telemetry backend. Whether that is Prometheus, it could be Jaeger, it could be OpenSearch, it could be a vendor solution. It really depends on whatever you would like to do. So you can say that OpenTelemetry is really about standardizing how we are collecting all the telemetry, because then we can do it once and we don't have to do it again, and then we can ship that data off to somewhere else where we can, or to multiple places. It's really up to you how to configure it. So it could be in the vendor space where Dasero is operating, or any other of the vendors out there. So if you see at the bottom, it's about generating and emitting. It's about transmitting. It also includes a transport protocol. It's the collector that it's basically in charge of collecting, converting, processing, maybe batching up things, and then exporting it to some backend. And then again, using the OTLP, the OpenTelemetry protocol, to send data to some backend. So why OpenTelemetry? I think I've already alluded to that. You can instrument this once, and you can basically use it everywhere. You can send it to wherever you want to send your data, because it separates the telemetry generation from the actual analysis, which is the really cool part of this. Before you had like a proprietary agent running in your cluster. Maybe some of you already have that, and it can be really, really hard to get out of that because you may already have instrumented that into your applications as well, and then it just becomes even harder. So OpenTelemetry is really about standardizing that and making sure that we are using the same standard for how we are generating and emitting telemetry. Also, OpenTelemetry is making software observable by default, because many libraries and frameworks and also CNCF projects now come instrumented by default. So if you're using Java, for example, you will get a lot of things out of the box, such as HTTP requests, database queries, messaging, all kinds of information is already instrumented for you. So you can actually do that without touching the code if you want to. And it improves how we use telemetry, because we can now start to correlate the different signals like logs, metrics, and traces, which then is really, really powerful when you need to investigate and dive deep into an incident. So why should you care about debugging? Well, it's a very powerful tool. It has a lot of different components. I think the GitHub organization of OpenTelemetry is over 80 different repositories today, so there's a lot of things going on. It's very complex. It can be fairly easy to misconfigure and really hard to diagnose, because it fails silently in many cases, which of course ends up as a result in your backend, whatever it is, that there's no data in your dashboards, or you don't have any alerts firing. So having some kind of debugging skills in an understanding of how this works equals hopefully more reliable observability for your solution, whatever you have running. So an OpenTelemetry pipeline could look something like this. We have the application and the client, where we are using the SDKs to implement the API specification, and then we export the data to somewhere. Usually that's through OTLP, the OpenTelemetry protocol. We define our receivers in the collector, as we have in the middle, and then we send it through some different processors. Processors in this case can be many different things. It can be like for batching things up. It can be for maybe handling memory limits within the processor. It can also be for redacting certain data or transforming data into something else, or enriching all your data with, for example, KDS attributes, so giving pod names and deployments names and all of these things added to your telemetry, so it's easier for you to dive deep into all the details afterwards. And then we have the exporters at the end. Export to whoever you want to, multiple places. This is the cool thing about OpenTelemetry. You can basically test out all the vendors in this space, send the data to 5 different vendors, and figure out what solution is the best for you. This is really, really cool. Or you can use it you can even use OpenTelemetry to collect Prometheus data, like defining the Prometheus receiver to actually go out and scrape the metrics and then store your data in Prometheus, if that's what you like. So it's very configurable. It's really up to you how you want to do this. A pipeline, this is a snippet from a configuration in the collector. This is just to show you how it's sort of defined. You define a bunch of different receivers, how you want to receive the data, how you want to process it, and how you want to export it. And then at the end of the file, you build your pipeline. So for logs, in this case, I want to receive it through OTLP, and I have the file log receiver, which is a receiver that goes out and picks up log files from local machines. So similarly to what FluentBit or FluentD does, or Logstash, or whatever you have running. And then we run it through different processes, in this case KDS attributes, to give some additional metadata around the infrastructure. We can also do resource detection, so it can detect that I'm running in DCP or AWS or whatever it might be. And then I want to export it to somewhere. So in this case, I'm just exporting to Dasiro for logs, and for metrics, I'm sending it to Prometheus and Dasiro, and so on and so forth. I think you sort of understand how to assemble these pipelines. It's fairly simple once you sort of defined your receivers, your processors, and your exporters. Then the common pitfalls. So most common mistakes end up with something like this, right, where you are seeing a dashboard, but there's no data in the dashboard. And this can come from many different places. It could be the wrong protocol or port you're sending data to. It could be that you didn't add a service name, and we'll look more into this in a second. It could be span context from your traces has not been propagated correctly. You could also start a span, but you never end it. You can do mismatching of the semantic conventions within OpenTelemetry, which result in some weird cases in some vendor tools, maybe. You can initialize the SDK too late, so you won't get any telemetry. And you can, even on shutdown, you can forget to flush the exporter, and then data will still be around, and then you'll have a broken trace. So all kinds of potential issues and common mistakes, and we'll have a look at a few of them. The first one is sort of the incorrect export configuration. Usually this is a protocol mismatch that you are trying to send HTTP to a gRPC port, and that will not be accepted. And what you will see in a second is that the SDKs have different defaults, which makes it even harder between the different languages. So you should really understand when you are choosing a language, what is the defaults, or actually be very specific on what you are sending and what you are expecting to receive. Another one is the incorrect service name. If you don't add that, it's usually required for doing trace correlation and stuff like that, and it will end up in many cases as unknown service, which is a bucket you probably are not expecting to search for. So that's why you probably don't find it. So it's always a good recommendation to make sure to set that either via code, environment variables, or whatever. Some of the SDKs have defaults that it defaults to something, but yeah, make sure to set that. That again is always a good recommendation to do that. Then context propagation. This is also very dependent on the language, because in Go, for example, you need to propagate the context yourself. In Java, when you do auto implementation, all of this is handled for you. So again, this varies very much depending on the language, and it leads to orphan spans because. If you're familiar with how traces work, this is the span context object. We have a trace ID, which is the entire ID of the trace. Then for each of the spans we are creating, we have a span ID for that. And then the parent ID of an object is this, sort of the span above it. I'll show you it in a more visual way in a second. Then you give it a name, you give it a kind, is it a client or a server side? Start and end time to be able to calculate the duration, and then a status code whether or not this is good or if it's failed. And yeah, maybe just if you're not familiar, onset is okay, which is a little bit weird. But it looks something like this, just to make it very simple, so that in service 1, trace ID is 1 and span ID is 1. In service 2, which is sort of the span afterwards, then we have the parent ID of the one on top, which was span ID 1. And then we generate a new ID, which is 2, and then so on and so forth. That's really how it works. And all of this is based on a W3 trace context, so we are like forwarding this using this this trace context, and you can read more about this if you like. But it will look something like this. This is just to tell you this is how distributed tracing sort of work in a very simplified way. Yeah, so back to the context propagation. So if you forget to propagate this, then you would either, in some cases, end up with multiple traces. If you forget to propagate it, you will have like one part of the trace will be this, and then the other part will be this, and it's not possible to correlate. So make sure you're propagating your context all the time. Then initialization and shutdown issues. I mentioned this before, but it also very much depending on the language when to initialize. For Go, I will show you that in a second. Also, that if you don't initialize the trace provider, you can create a trace. It looks like you're creating a trace, but you will not have any data. And also make sure that you're actually remembering to do proper shutdown handling, so that you are flushing the SDKs, etc. Some of them do this themselves, some don't. So that is also a common error that we see quite a lot. And again, if you forget to do some of this, it will result in no spans or broken traces, which is kind of hard to figure out when things then go wrong. The last thing, I should probably speed up a little bit, I can see, is that if you're not, semantic conventions evolves over time. So for example, HTTP method was what the default before. Now it's called HTTP request method. So semantic conventions defines how these different attributes are named, what they are, what they should represent. It's really, really nice, but you should remember to continue following the latest versions, or select a tool that helps you do that, so that you're always on the newest version. But I guess that goes for all software in general. So language-specific challenges, because this is really where I want to spend most of my time. For Java, if you're not familiar with Java, what it does is that when you instrument and use auto-instrumentation in Java, it uses the Java agent flag. You basically download the Java agent, and then you say, Java agent run this, or java.java agent, and then the jar you want to run. And what it does is that it does a lot of bytecode manipulation. It auto detects what kind of libraries you are using, and then it basically adds the relevant instrumentation to that. And then it does automatic context propagation for you, so you don't need to do that, which is quite nice. And it does that through the trace headers and the trace parent headers, HTTP headers. Yes. So I wanted to demo this a little bit, so I created actually asked ChatGPT to help me with some Japanese-themed demos, so I hope I'm not offending anyone. So it came up with this tea ceremony tracer, which is a small Spring Boot web application that serves a tea endpoint, returning a random Japanese tea type and a temperature. So let's just jump into that. So what I have is, I should take this down. There we go. So I have this repository, and all of this is available, so you can find it afterwards. I will have a QR code for you, but it's all very described, so you can follow it afterwards as well. So if there's something you are not following, just check it out afterwards. So the idea about this is that I have, hopefully you can help me a little bit, if I can hit it. I have something where I've broken this on purpose. So in this case, I want to run a simple jar file, and I want auto-instrumentation. So I want to do this. I just want to run this. I want to configure it with a service name. I'm setting the OTLP protocol to be gRPC, and I want to send this to my local host 43 because I have this collector running, debug collector, which is basically just I'm running a Docker container so that you can see that we're actually receiving data. So let me just run this. Debug. So we can try and run this, see how it works, and see that we are seeing a Spring Boot application starting up. It's fine. We can do curl t. There it is. So the service is responding with some t and some temperatures. I'm not sure if this is correct, but but we don't get any telemetry. I'm searching for T service. I'm not seeing anything. And the reason for that, anyone has a guess? No. Instrumentation, correct? So I didn't download the actual Java agent, so that is what I'm doing here. And then I'm using the Java agent flag and giving it to the Java runtime. So this is how you do auto-instrumentation in Java. So if I run this again, now the fixed version, you should actually note up here, you can see this line. It tells you now that the Java agent is now running, and now this will be auto-instrumented out of the box. So if we do this again, if I can hit the keyboard correctly, maybe just up. And now we see we get things in this debug collector. You can see there's some, what is this? This is a trace, no, this is a log record with a trace ID and all of this set. So we also now already include trace ID and span ID in the log, so we're able to correlate afterwards, which is quite nice. So this works, but this can be a little bit hard to sort of visualize, so I also added a Docker Compose setup, Docker, which basically runs Prometheus, it runs Jaeger for tracing, and it uses OpenSearch for logging. And it's just to show you sort of the visualization of these things, that it actually works. Because it's a nice thing to have locally, that you can actually debug this locally, and you can see that you're actually receiving the things, and you're setting the correct resource attributes, etc. So if I go back here, I refresh, I log in. I should probably also send a few requests before. You should have some tea. Hopefully there's some tea now. And, ooh, this is exciting. Live demos are always fun, right? Seems like the pattern didn't actually work. Okay, we'll take the Jaeger for traces instead of the logs to start off with. You can see that we have the T service here, and you see the different traces. You see all the data are coming in, all the semantic conventions are being followed correctly. This was the T endpoint, yada, yada, yada. All of this comes out of the box. The same, hopefully, for Prometheus. We just execute this. That was a HTTP request. Let me just zoom in a little bit. And we see that this is from the T service, and it was hopefully on the T endpoint somewhere. I don't actually see it, but it's coming from the T service, so we are getting metrics in, and maybe just a quick refresh over here and see what's happening. No, okay. We'll skip the logs for now, that's fine. So back to this one. So that was Java. That's really how you easily can get up and running with Java using the Java agent. It's fairly quick. It's very simple in Node as well. It's more or less the same method where you're sort of defining something on when you're running your application. In this case, it's just a require. So you can require the auto implementation and then run with your app. As you can see at the bottom, it does a lot of things as well, just as the Java agent. It patches, finds the different modules you're using, and then it does some things under the hood. It also do context propagation out of the box, which is quite nice. So for this, the ChatGPT helped me with a ramen ratings API. So thank you for that, ChatGPT. So let's have a look at that. It was this one, so I'll go back, cd node. And again, let's just have a look at the broken one, because this should be more or less the same. So now I'm actually configuring the auto instrumentation using the node options. I'm configuring a service name, and I'm setting the OTLP endpoint, similar to what we did before. Any guesses of what will happen now? No? That's actually, so the Node SDK defaults to HTTP protobuf on that port. So, and now we're trying to send that to a gRPC port. So it's actually failing it. And as you can see right now, there's we actually get an error here. But if we query the service, ramen, works fine, right? So it doesn't really break our application, which is nice. Of course, our telemetry should not break our service. But we just don't have any data. And we can see that if we close this down very quickly. I'll just run the debug container one more. I think OpenSearch is playing a trick on me today. It usually works quite well. Debug collector, and we'll send a few more requests. Search for ramen. No. So no ramen over here. So what we do to fix it, let me just find the fixed one. Wow, I'm bad at typing today. So for this, it's actually a little bit more complicated than, you can fix this for tracing using just setting the protocol as it is right here. But I also wanted to make sure that this worked for the metrics and for the logs as well, and that's a little bit more complicated. So I needed to add my own instrumentation, and I don't have time to go into all the details, but you can take a look at those. It's in the instrumentation.js file if you want to see the repo. But by default, it works with tracing, but logs and metrics are a little bit different in the Node.js SDK. It's not that well supported as traces, so just note that. But let's just see it running. Run demo fixed. And now it's running. We send some requests, and now we see data is coming in. So having this debug collector running makes it very easy for you to sort of see how is my telemetry being produced, what kind of resource attributes are being added. All of this is quite nice to debug locally. I will skip the full because I'm running low on time, and then I'll just quickly go back to the slides and talk a little bit about Go, because Go, as mentioned earlier, is very different than what you just saw, because there's no auto instrumentation here. You can do some eBPF auto instrumentation if you want to. Currently there's some security concerns in that area, but I know that's being fixed. A lot of fixes being done to actually improve this. But right now, if you want to do this, you can do manual instrumentation, and you import. You do a lot of things in Go, and I will just show them to you. Oh, I should show you the demo. Sakura start service, right? So. CD back, CD3 Go. So this one is actually a little bit, it runs, I have a broken Go service because now I need to instrument things in code. And what it does is that it basically just has an endpoint, Sakura, and then it gets the context from the request. It starts a trace called Sakura, and sets the context and names it, and then it defers span end, so it's actually ending the span. So if you try to run this, broken, and Sakura, it works fine, but we don't get anything here, right? Any guesses to why that is? While I find the fixed one. No? It's because what I said earlier, and again, there's a lot of code here. You don't have to. The important part is really setting a trace provider. This is where you're sort of defining and telling the OTel SDK that this is the trace provider I want to use. So this is what is needed to actually get this up and running, and then it works. And if you're implementing the same for metrics, you need to set a meter provider, and for logs, you need a logger provider. So that's how it works in Go. Fixed. This, let me just show you that it actually works. Sakura. There we go. Then we actually have a metric called Sakura petals count. So we can see metrics, we can see logs, we can see traces visualized in the debug collector. And you can of course also see this in the full demo online if you download it and run the Docker Compose setup. But I have 3 minutes left, so I will just go back to my presentation. And so there's a lot of differences between the SDKs and how to use them. As you saw, some are actually like defaulting to HTTP protobuf, some are defaulting to something else, different ports. There's different ways to configure if you want to do like console logging, which is also possible. I didn't actually show you. I can just quickly show you that because that doesn't take a long time. So if we quickly take the node demo, I also have this run debug that basically instead of sending things to the collector, it just outputs the console logs, whatever it's doing. So you can also do it like this, so you can see all the different attributes, etc. So that's also a way for you to debug your SDKs, which is quite nice. But again, here's the difference in that in Java and Node.js you can use OTel trace exporter or logs exporter or metrics exporter, but it's console. But for Go it's the standard out, so it's different. So just know that context propagation also covered that. Be explicit in Go. Make sure to pass the context object, because otherwise you will have broken traces. And best practices and tools. I really recommend using the collector as this central routing layer in your environments. It's a really, really good agent, observability agent, whatever we call it, to have running, to also get all the metadata from your Kubernetes resources, etc., so that you can actually enrich the telemetry with all the right attributes. And then you can send it to wherever you want. The checklist, make sure that protocol and port is matching. Make sure to understand and read about the languages and SDKs in whatever language you're using. Set the service name. Make sure to initialize the SDKs early and end all the spans. Use these debug console loggers. It's a really good tool. The same with the debug container that I showed you with the collector. It's really nice to have that locally. Follow semantic conventions. Make sure to upgrade whenever you see new things there. This is just a summary of some of the environment variables, and then the debug collector, how you can run that locally in a one-line command. And other great tools, OTelBin, it's a great way to visualize your collector config. So if you want to see that visualized, it's an open source tool we did at Dasero. You can put in the config, you can verify and validate against different collector contribution or distributions, because there's also a difference there that it's quite annoying when you don't know that you're trying to use a receiver that is not part of the distribution you're using. So that is a good way to validate as well. I'm running completely out of time now, so OTel Run, if you're transforming things, have a look at that. This is created by Elastic. It's a great tool. And it's not only about getting things running, it's also about emitting good telemetry. So good telemetry is really structured, contextual, correlated, trustworthy, and useful. That's really things that you should make sure. And then, of course, remove all noisy data, redundant data, inconsistent data, and make sure that you're actually propagating your spans correctly. And telemetry without context is just data. So add all the context you can, because it's really what will help you when things go wrong. And I don't have time for that. So thank you so much. You can check out this QR code. This is the demo. You can find it online, and you can play around with it yourself. And yeah, if you want to chat more, come by the booth at Dasero. We are just outside the keynote hall. Thank you.